Let's talk about the second review, pre-cal, first 6 weeks. Number one here, we have the first A, B, and C are combining functions or function arithmetic. We've got G minus F, we've got F divided by G, we've got F times G. Let's work a quick example. I will do C. Actually, I'm going to do B. Let me give myself a little room here. So I have F divided by G of X. This means F of X divided by G of X. And so I plug everything in. F of X is negative 3x plus 2. G of X is x squared minus 4x minus 12. So now I ask myself, is there anything that I can do such as combine like terms on bottom or top? The answer is no. Does anything cancel at this point? The answer is no. Can I factor anything? And the answer is maybe. So I check to see if the bottom is factorable. My signs are going to be different. The biggest one is going to be negative. A is 1, B is negative 4, and C is negative 12. Multiply A times C, you get negative 12. Remember, you don't have to worry about this negative sign here because your signs are taken care of up here. So you list the factors of 12, or each two numbers you can use to multiply together to get 12. And you got 12 times 1, 6 times 2, and 4 times 3. But if my signs are different and the biggest number is negative, which set adds to negative 4? And that's going to be these two. So I take those two numbers, negative 6 and 2. My next step is to divide by A, which is 1. The next step is to reduce if I can, and I cannot, so X goes with the number on bottom. So I have X minus 6 and X plus 2. And remember, can't stop there. That was just us factoring the bottom. So what I have to do is go back and plug this in to my denominator. So I have negative 3x plus 2 over this thing down here that I factored, x minus 6, x plus 2. And so now I ask myself, does anything factor? And the answer is no. So we're done right here. This is all you can do. There's nothing that cancels. There's nothing to combine. We're finished. That is my answer. And that's how you will do each one of those problems. Whether you're subtracting, I will tell you to be careful when you're doing the subtraction, because remember, if you have G minus F of X, what that means is G of X minus F of X. And so when you write G, nothing to worry about there, just write the function G down. However, when you subtract, pay attention to this, when you subtract, you must open a set of parentheses, because this one thing, F of X, I'm subtracting F of X here, but it's about to become two terms. And so I'm going to have to, at the end here, I'm going to have to distribute this minus sign to each one. So be careful when you're subtracting, so to open up your set of parentheses for the distribution of the minus sign. Okay, so that takes care of that part. Now, let's go down here and let's look at C. C, this bottom set of A, B, and C down here, these are composition of functions, or functions of functions. This is where you plug one function in to another function. So here we want to do G of F of X. That means we want to plug F of X into G. So what I want to do first is find the inside. You always work from the inside out. Write down F of X. What is F of X? Well, F of X is still this thing up here, negative 3x plus 2. but I want g of this. This right here, this says g of f of x, because f of x is negative 3x plus 2. So the way I do this is, I rewrite my function using a set of parentheses everywhere I have an x. X squared minus 4x minus 12. Then I want to insert or input what's in here over into here. Negative 3x plus 2, negative 3x plus 2. Now this one, there's going to be quite a bit of stuff going on. First of all, you should know right here, this means I'm going to have to box or use the FOIL method for this, because this negative 3x plus 2, all of it being squared, is really this. It's negative 3x plus 2 times negative 3x plus 2. Here I can go ahead and simplify. I'm going to distribute the negative 4 or the minus 4. Minus 4 times minus 3x is going to be plus 12x. And then minus 4 times a positive 2 is a minus 8. And then I'm going to bring my minus 12 back in. Now I could either FOIL or box this. Since I already have it lined up here, I'm going to FOIL it. It'll be the first two terms multiplied together. Negative 3x times negative 3x is 9x squared. Then the outside two terms multiplied together. Negative 3x times 2 is minus 6x. Then the inside two terms multiplied together. 2 times minus 3x is minus 6x. And then finally my last two terms multiplied together. 2 times 2 is plus 4. And then I'm going to bring everything else back down. I've got a plus 12x. But I'm going to go ahead and simplify this. I don't have to. I could bring it all down, but I'm just going to do it while I've got it here. Minus 8 minus 12 is minus 20. Now what I want to do at this point is look at all of my like terms. So I have a 9x squared right there, and I only have one of the x squared, so I write that down. So I have 9x squared. That one's gone. I can just put a mark through it. It's gone. Now I'm going to look at all my x's. I have a 6x, minus 6x, another minus 6x, and a plus 12x. Well, minus 6x minus 6x is minus 12x. And then a minus 12x plus 12x cancels. That becomes 0. So the x's are gone. And then I have a plus 4 and a minus 20, which is a minus 16. Now you may think you're done here. But what you really have here is the difference of squares. 9 is a perfect square, x is being squared, 16 is a perfect square. So my real final answer here, the simplified answer, is going to be 3x plus 4, 3x minus 4. That is my answer. Okay, also in the directions and on the test it says to give the domain. So if I go back here and look at my domain, since I do not have any radicals, I don't have any fractions, there's no possible restrictions, so my domain is all real numbers. Back up here to part B, where I did this problem, I have two possible restrictions. Okay. X cannot be 0 on bottom of a fraction. So what I do is I take the bottom, this x minus 6 times x plus 2, and I set it equal to 0 to find what my restrictions are. So I would have x minus 6 equals 0. And I would also have x plus 2 equals 0. So when you solve for x in both of these cases, you get that x equals 6 and negative 2. These are my restrictions. This is what x cannot be. And so how I write that is, let me give myself a little room. How I write that is, the domain, if I'm looking on the number line first of all, Look right here. Maybe this will help you with the people that are struggling with this. I have two numbers that x can't be. I have -2 and I have +6. So that means that x can be any number to the left of -2 all the way out to -infinity. X can be any number in between -2 and 6. And x can be any number from 6 all the way out to +infinity. Now, the numbers that x cannot be are these values, -2 and +6. So the way I write this in interval notation is I start out from the left with -infinity, comma, I'm coming all the way up to -2, and I'm going to use a set of parentheses because that -2 is not included, union, parentheses, then I'm starting back over at -2, all the way to 6, again parentheses because -2 and 6 are not included, union, and then finally 6 all the way to infinity. And that's how you would write that domain. Okay, let's look real quick at number 2 here. Use the composite functions to fill in the blanks. So what we have here is we have two functions. We have f of x and we have g of x. Now the important thing here to notice is, look what's inside the parentheses here for f of x. What's inside the parentheses here is x, my independent variable, which goes here. Okay? What's in the parentheses again is my independent variable, and it is my x values up here. Same for g of x. What's in parentheses is my independent variable, and it goes up here. So when I'm filling in this function down here, I have g of f of x. Well, what's inside the parentheses here, my independent variable, is f of x. F of x here is now my independent variable. So I go up here where f of x is. These are my new x values that I'm going to plug in. Actually, that doesn't give me that. Let's change this problem really quick. I want it to be like the homework problems that we did. Just blot those x values that you're given there on your g of f of x function. Now, what's inside the g here, this f of x, is my independent variable. That means that these f of x values here are now my independent variable, my x values. So I plug these values in here. 5, 3, 1, 2, and 4. So now, since I'm talking about the g function, I go here to my g function. That's this one. Sorry. This function here. And I want to use that to find out what g of f of x is. So what this is saying is that on the g function, right there on the g function, when x is 5, what's y? Well, it's 2. When x is 3, what's y? 4. When x is 1, what's y? 3. When x is 2, and when x is 4, and so on. Now, I wanted to change this because I wanted it to look like more of the homework problems that we were doing. But if you were given those x values, what you would do, I think that might have been a little bit of a typo. So let's just stay with doing this. Let's erase those x values. And let's go with that. That's what you're probably going to see on the test. Okay, moving on to number 3. It says use colored pencils to graph the transformations. Now we have two different types. We have this type where you're already given this function that's drawn here. You have 1, 2, 3, 4 ordered pairs, and it wants you to do these transformations with those ordered pairs. You also have this type down here. Now this type down here, you do not have something graphed, but what you do have is a function that you can recognize the parent. And the parent function here is f of x equals x to the third. The parent function here is f of x equals the greatest integer of x. Okay? And the difference would be these two, you would have to start with your parent function and then do the transformations that's given. These up here, you just take this function, what you're already given. As a matter of fact, I'm going to do this one. We have these 4 ordered pairs, and we want to take this function and we want to transform it like this one. This means that, and I'm going to go in order, inside parentheses first, we're going to go left 1 unit, and then we're going to multiply the y value. This 1/2 out front means we're going to multiply the y value by half. And then finally, this piece out here means I'm going to have a vertical shift down 3 units. So if I take each point and do that, I'm going to start on the left side here. I'm going to go left 1, that puts me here. And then I'm going to multiply the y value by 1/2. But the y value of this point where my little pencil's at is 0. So 1/2 times 0 is 0. That goes nowhere. Now I'll go down 3. That point goes to there. Now I'll take this point. Left 1, multiply the y value by half. The y value of this point where my pencil is 3. 3 times 1/2 is 1.5, or 3/2, and it takes me to there. I shouldn't have marked that. Now I go down 3 from here. 1, 2, 3. That point goes to here. Use different colors, and if you want to make little dots as you go along, that's fine. Just be very careful of what you're doing. Now at this point, I want to go left 1, multiply the y value by half, takes me to here. And then I'm going to go down 3. 1, 2, 3. And then finally my last point, left 1. The y value is 2. Multiply it by half takes me to 1. And then down 3 takes me to here. And now I just connect those dots. And that's my answer right there. My lines could be a little straighter. Okay, so I guess we'll look at the cubic function here. You should be able to recognize that the parent function is f of x equals x cubed. So what I want to do is make myself a t-chart, x, y values, and if f of x is equal to x cubed, I want to find, remember you always want to start with these values for x, I want to find f of -2, f of -1, f of 0, f of 1, and f of 2. So I'm simply just going to rewrite my function f using a set of parentheses everywhere I have an x. Then I'm going to input this x value, and then I'm going to simplify. Well, you have to remember that I have a negative number here being raised to an odd power, so that's negative. That'll be negative 8. This will be negative 1. 0 cubed is 0. 1 cubed is 1, and 2 cubed is 8, so I have myself these ordered pairs that I can plot. Trace that function out. And then you want to move to a different color. Make sure you can see these ordered pairs, because these points are what we're going to use for this transformation. So what I have going on here is left 2 units, and then I'm going to, at the same time, I've got 2 things happening out here. This negative sign means I have a reflection in the x-axis. This 1/2 means that I'm having a shrink, a vertical shrink. So I can take care of that at the same time by multiplying the y value by negative 1/2. So I'm going to multiply the y value by negative 1/2. And then finally, this plus 4 out here is a vertical shift up of 4 units. So each one of those points is going to undergo that transformation. And I'll start here. So I go left 2. Now I'm going to multiply the y value by negative 1/2. The y value here is 8. 8 times negative 1/2 is negative 4. So that takes me down to negative 4. But then I go up 4, so that point now goes to here. Now this point, left 2, y value by negative 1/2, this is 1, so 1 times negative 1/2 is negative 1/2, which puts me down here. Uh-oh. That's nice. Let me put this back really quick. Been having a lot of technical difficulties today. Just replotting the parent function. And now I'm going to do my transformations one more time. Things are going to get kind of tight in here because it's shrinking vertically, so be very careful with your points. Let's try this again. So left 2, multiply the y value by negative 1/2, so I'm down here at negative 4. And then up 4, so that point went back to the origin. Now this point, left 2, multiply the y value by negative 1/2, takes me to negative 1/2, and then up 4. 1, 2, 3, 4. And take your time and just make sure you do the counting correctly. You can go back and do it twice. Now I'm at the origin, left 2, multiply the y value by negative 1/2, which stays at 0 because the y value is 0 where my pencil is, and 0 times negative 1/2 is still 0, and then up 4, so I'm here. And then this point, left 2, multiply the y value by negative 1/2. The y value here is negative 1, and negative 1 times negative 1/2 is positive 1/2, so I'm here. And then up 4, 1, 2, 3, 4. And then finally, left 2, multiply the y value by negative 1/2. Negative 8 times negative 1/2 is positive 4. I'm up here. And then up 4, 1, 2, 3, 4. I think I missed one. 1, 2, 3, 4. And then sketch it out. And that is my answer. Just take your time. Make sure you start, and I'm sorry that it all disappeared, but make sure you start with your t-chart, your parent function, If you don't have that, you're going to have half points off. Make sure that you plot those points. I would also recommend that you write out your transformation before you start. Take your time and write left 2 units. Multiply the y value by negative half. Then go vertical up 4. On number 4 here, it says determine if functions are even or odd using their graphs. All you're going to do here is you're going to use your graphing calculator. You're going to put these in y equals and look at the graph. If it has y-axis symmetry, that means that it's going to be an even function. Okay? Now make sure, we had a quiz, and I'm just going to make a problem up here really quick. If this is my xy plane, and if I have a parabola that looks like this does not have y-axis symmetry, because the y-axis is not acting as the line of symmetry, making the left side look exactly like the right side. This right side is much bigger than the left side. This also does not have origin symmetry, because it doesn't look the same way it does right side up as it would when you turn it upside down. So this one would be neither. Okay, don't make that mistake. If it has y-axis symmetry, it's an even function. If it has origin symmetry, which means that when you look at it the way it is and turn it upside down, they look exactly the same. So be careful there. Number 5, we're going to be looking at taking some points and then creating either an even or an odd function or both. We did a lot of this on the quiz that we took a week ago. So quickly, I will do an even function. To make an even function, the first thing you want to do is plot the points you're given. So we have 0, 2, 3, 4, negative 2, 5, negative 7, 1. And then make sure you plot those points right, because I make mistakes sometimes on plotting points too. So just double check yourself. Take your time. Alright, so the first step was to plot those points. The next step is to rewrite those points. For an even function, you change the x value signs. And if you're doing an odd function, which I'm not going to do this, I'm going to leave this one to you, you would change both x and y signs. Okay? So we changed, we plotted our original points. Now we need to change our signs. And so that gives me the signs of the x values, that is. Well, 0 doesn't have a sign, so that remains 0, 2. Then I get negative 3, 4, positive 2, 5, negative 6, negative 3, and then I also have, let me give myself a little room. I also have positive 7, 1. So all I did was change each x value's sign to the opposite. If it was positive, it's now negative. If it was negative, it is now positive. And now I want to plot these points. And it might help you to use a different color here. It's not necessary. If you think that you can do it with one color, you're not going to get confused, maybe, because you're going to connect all the dots together. But I like to use different colors anyway. So 0, 2, that stays the same. Now I have negative 3, positive 4. And as you're doing this, with these even functions, you should notice that when you're plotting these new points, you should have another point that's symmetrical in the y-axis with it. And there's that one. Now I have 2, positive 5. It's symmetrical over here. Now I have -6, -3. And I am noticing that I made, where did I put 6, 3? Did I erase it? 6, -3 should have been over here in black. Let me check my original points. 0, 2, 3, 4, -2, 5. I skipped 6, -3. That point goes there. And the opposite, the -6, -3 came over here. So see, I left a point out, made that simple error. Make sure you're taking your time and being very careful. And then finally I have 7, 1. Now every point has a symmetrical point, and now I connect the dots. Now this was a problem on the test a lot of people had. A lot of people wanted to go from here up and then over to here, but if I do that right here, I fail the vertical line test. So it is very important that when you do this, you go to the far left of the graph and go to the far left point, and then look for your next left point. And when I'm talking about left points, I'm talking about using these vertical lines here. So I go here and I look, is there a point on this vertical line? And the answer is yes, it's right there. So I go to it. Then I come down here, is there a point on this vertical line? No. Is there a point on this vertical line? No. Is there a point on this vertical line? Yes. So I draw my line to it. Then I say, is there a point on this vertical line? Yes. Draw my line to it. Is there a point on this vertical line? No. Is there a point on this vertical line? Yes. Draw my line to it. Is there a point on this vertical line? No. This one? Yes. This one? Yes. Is there one on this one? No. This one? No. This one? Yes. This one? Yes. And I'm done. If you'll take your time and go to each vertical line like that, you'll be fine. This function, no matter where I draw a vertical line now, it will pass the vertical line test. Because remember, we are creating functions. They must pass the vertical line test. Number 6 says find the equation for f of x equals the absolute value of x with the following transformations. I'm going to let you do this one on your own. You'll look at note card 17 and make sure that you're giving this a reflection across the x, which means the function needs to be negative. It's going to have a vertical stretch by a factor of 1/4. Now, when I say a vertical stretch by a factor of 1/4, remember, you should probably remember this from Algebra 2. If this factor you're stretching by, and we called it C on the note card, so I'll call it C here too. If C is greater than 1, then that's a stretch. If C, however, is between 0 and 1, or in other words, if it's a fraction, then that would be a shrink, okay? So by saying it's a stretch by a factor of 1/4 really means it's a shrink, okay? And then there's going to be a vertical shift down 3 units. So you would want to put that where it belongs, and then be careful with this horizontal shift. It goes inside the parentheses, but I'm going to let you handle that one on your own. Number 7, you will refer to note card 11, where it talks about the different types of discontinuity, whether it be a jump, removable, or infinite. An example quickly of a jump. You might be starting here and coming along, and maybe it stops here, and then there's a break. Then maybe it picks up back over here and does like this. That's a jump. Because imagine if this was a hill and you were walking along or running up this hill, and you got to this point and you had nowhere to go but to jump up. Okay? Removable. I guess I'll go ahead and show you. If you have a function that maybe starts over here, and then maybe it has some point where it's not defined, but it continues and like this. But somewhere on the vertical line above or below this point that's not defined where the function is actually being drawn at, this is removable. It's a removable discontinuity because if I pretend for a second that this point right here is not there, there is some discontinuity in this graph. There's a break. But because this point remains on the vertical line where that point is not existing there, we can actually plug it back into there, and it's actually, you can remove this discontinuity. This is removable. And when you have infinite, this is where you have a place where, like the parent reciprocal function, it has infinite discontinuity at x equals 0 because there's this vertical asymptote. Again, refer to note card 11. Number 8, you're going to have to sketch the parent functions. Look very carefully at this part. Without looking at the note card. So there's going to be a lot of those functions you know, but there's going to be some that you're not very familiar with. You're going to need to study that parent function handout to be able to do this. Remember, your time is limited on the exam. And that'll do it. So make sure you study those parent function note cards and ready for this test.